Good day, wizards. Welcome to your lesson for trigonometry. What have we learnt about trigonometry? We learnt about some general rules of trigonometry. We learnt about trigonomic ratios such as sine, cos and tan. We also learnt about their reciprocals such as cosec, cot and sec. Now trigonometry has various different applications. If we look at the periodicity of trigonomic functions, when we look at that, we look at 360 degrees. What that means is that there is an infinite number of positive and negative angles that can satisfy a general solution. If we do not restrict that solution, then we need to determine what that general equation is. So what that is basically saying, if we do not restrict a period of time, either from 0 to 180, 180 to 360, 90 to 180, if we don't put some restriction on the period, then we need to give a general solution. We know that sine and cosine both have a period of 360 degrees. We learned that when we were doing graphs involving sine and cos. We learned that the period it takes for one complete graph is 360 degrees. We learned that to achieve a tangent graph, it takes a period of 180 degrees. Why does it take 180 degrees in tan? We learned that tan has two asymptotes. Those asymptotes are lines where the graph will approach, but it will never touch. Therefore, the only period or the only full graph is given at the middle of your tan graph. So in order for us to determine a general solution, we can use various different methods. Now, there are some methods, such as 6 methods that we can use. We can simplify the equation by using algebraic methods, and then we can introduce the trigonomic identities. We can determine a reference angle by using a positive value. We can use the cast rule. What does cast rule do? Cast rule represents the quadrants in which the identities are either positive or negative. So remember that when we jump in our example. We can also restrict the values or find the angles that lie between that specified interval by either adding, subtracting the multiples of that appropriate period. One of the other ways is to find a general solution. That general solution can be used to find the angles in the interval of 0 and 360 degrees that will satisfy the equation. And then we can add multiples of the period to each answer. The last way in order for us to use the method is for us to check our answers using a calculator. So these 6 methods may be used at all times when trying to find a general solution. Because it's really confusing for us to know each equation or for each step or for each analysis, it's quite hard for us to remember the sequence of things. So let's jump into an example and see if we can combine what we've been learning for our 6 methods into one example and see if it's easier for us to work with it thereafter.
So if I want to look at what are some general solutions, I can start by saying there are some general solutions for sine, cos and tan. So if I were to look at these 3 general solutions for trigonometry, these are 3 standard general solutions and we're going to go through them really quickly. And then after that we can look at doing an example on our own. So if I have the general solution, so it says if sine theta is equal to x, then theta is equal to arc sine. So what that means is it's arc sine x plus k times 360 degrees. Remember, k is your constant. So we can say then, or theta is equal to 180 degrees minus arc sine of x plus k times 360 degrees. Now, most of your general solutions will have or. There will be 2 options for most of your general solutions. That occurs because of your cast rule. So if I look for where sign is positive, I can look at the quadrant where all is positive as well as the quadrant where sign is positive. So if sign was negative, I would have two quadrants where sign is negative. So therefore, you are most likely to have two values or two answers for your general solution. The same works with cos x, where I have cos x, cos theta equal to x, where theta is equal to arc cos x plus k times 360 degrees, or 360 degrees minus arc cos of x plus k times 360 degrees. And then lastly, we look at tan x, where tan x is simply equal to tan arctan to the power 2x plus k times 180 degrees. And all of this is where k is an element of a real number. So this value of k can be substituted for any other value, as we'll see as we go along with more examples. But remember that k is a constant. And then if I were to move along and say, let's look at an example where I am asked to determine the general solution for sine A, where sine A is equal to 0, 3. What's the first step that I need to take? So my step 1 would be to find a reference angle. So to find my reference angle, I would go to my calculator. I would put arc sine of 0, 3, and that would give me a more less than 17,5 degrees. That means that 17,5 degrees is my reference angle. It's just a reference angle. My second step, so if I move on and I say, let's look at step 2. Step 2 involves us using the cast rule. So if I draw a little Cartesian plane and I put C, A, S, T, that is my cast rule. In order for me to determine which quadrant sign is positive, the cast diagram will indicate that it is positive in the first because it's all, and it's positive in the second quadrant. So by using the reduction formula, what can we say? We can say that sine into 180 degrees minus theta is equal to sine theta. That's the reduction formula. So what do we do then? We want to look at each quadrant individually. So I can say in the first quadrant, what would be my value? My first value or my first quadrant is simply where theta is equal to 17,5 degrees, which is the reference angle. And to write this in the general solution, I will get 17,5 degrees plus k times 360 degrees. Then I can look at doing the second quadrant. And in the second quadrant, I know that theta is going to equal to 180 degrees minus theta. Can we see that here? This theta represents our reference angle. So I get 180 degrees minus 17,5 degrees. And that's going to give me 162,5 degrees. And in my general solution notation, it will be plus k times 360 degrees. Now remember that you have to state for all elements where k is an element of real numbers. What you can do then as step 3 is you can go further to check your answer. So step 3 will be your check. For this check, you can say that you want to select any random value of k. So let's look at any random of k. Let's look at let k equal to 4. What would be the value? We can then say that theta is equal to 17,5 degrees plus 4 into 360 degrees because I substituted my value of k. That's going to give me 1457,5 degrees. And then if I put that into my calculator and say sine of 1457,5 degrees, and that's going to give me 0,3007. Rounded off, I get my answer of 0,3. You can try to do that for another value of k. So let k equal to, let's say, -2. Then we get theta is equal to 162,5 degrees plus, or we can say minus 2 into 360 degrees, because we're saying let k equal to -2. When I put that in my calculator, I get theta equal to minus 557,5 degrees. Once I put that into my calculator, sine of minus 557,5 degrees, what will I be left with? I will be left with 0,3007 and so on. Now when I round off my answer, I still arrive at 0,3. So you can see how we work that general solution, how we arrive at a general solution, and how we can check our answer. So we've got our general solutions and we've also checked our answer.
Well done, wizards. That example was really long and really tedious. But in order for us to determine general solutions, we need to look at how we can do it much faster by practicing more examples. What did we learn from the example? We introduced the concept of k, which was a constant. We also introduced elements of z, which was your elements of real numbers. Those are simple things that you need to remember. If those things are missing in your answer, then your answer is incorrect altogether. So those are little tricks that you need to learn and that you need to establish as a pattern going forward. If they are left out, you may even lose a mark in your test or your examinations. So those things are very important. It might seem like a lot of hard work, wizards, but in the end, it's all worth it because you will be awarded the marks for remembering those routine steps. So wizards, have a look at our iWiz website. They have extensive worksheets with extensive examples to help you understand this section. Remember that trigonometry is a hard section in mathematics and that you need to continuously practice it in order to become better at it. So go ahead and look at our website that's given to you and try to download those worksheets and complete as many examples as you possibly can. Good luck, wizards!
We need to learn to live with the COVID virus, the new normal, at least for the next few months. And we have just what you need to make sure you never miss a single school lesson. And it's absolutely free, mahala! High quality, powerful, animated lessons for all your subjects. So don't spend a cent until you have tried iWiz. It's everything you need. All video lessons, textbooks, workbooks, exam prep. We want you to ace 2021.